Hi there, this video is on rate of change, which is really just an application of slope. Rate of change is a ratio that compares the amount of change in a dependent variable to the amount of change in the independent variable. Now remember, we traditionally use y for our dependent variable, so the change in the dependent variable is really delta y. And the change in the independent variable would be delta x. Now you may recognize that from our slope video. So that's how we find rate of change. We're going to do an example. This graph shows the number of customers each day for 5 days. What is the rate of change in the number of customers from Tuesday to Friday? Well, rate of change, here's Tuesday, and here is Friday. So I'll make those two dots blue. We're looking for delta y over delta x from one blue dot to the other. On, let's see, Tuesday, there were 310 customers, and on Friday, there were 390 customers. From Tuesday to Friday is a change of 3 days. Tuesday, 1, 2, 3, there's Friday. So that's a change of 3 days. So what is the change from 310 to 390? That's a change of 80. 80 divided by 3 is approximately 27. So approximately 27 a 27 customer increase per day from Tuesday to Friday. In this problem, we have a table which shows the cost of mailing a 1-ounce letter in different years. Find the rate of change in cost for each time interval. During which time interval did the cost increase at the fastest rate? All right, our first time interval is from 1988 to 1990. The cost of a stamp was 25 in 1988 and 25 also in 1990. So the change in the dependent variable was 0, while the change in the independent variable was 2. That's a time period of 2 years. 0 divided by 2. That means that the cost of a stamp changed 0 cents per year. From 1990 to 1991, the cost of a stamp changed from 25 to 29, 25 to 29, and that's a time period of 1 year. Well, 25 to 29, that's an increase of 4 cents in 1 year. So that's 4 cents per year. From 1991 to 2004, the cost of a stamp changed from 29 cents to 37 cents. And let's see, from 91 to 2000 is 9 years. 9 plus 4 is 13 years. Now, 29 cents to 37 cents, that's a change of 8 cents in 13 years. Let's see, 8 divided by 13, that's 0.6, approximately 0.6 cents per year. And last, from 2004 to 2008, the cost of a stamp went from 37 to 42 cents. And that's a time period of 4 years. So from 37 to 42 is a change of 5 cents in 4 years. And when I divide that out, boy, this is precise. 5 divided by 4 is 1.25 cents per year. So to answer the question, in which time period was the rate of change the greatest, that of course would be from 1990 to 1991, when the cost jumped by 4 cents in that 1 year. In this problem, we're given a map, and on the map, it shows distances between cities in Texas, along with the average time it takes to travel that distance. Now, in our specific example, Juan drove from San Antonio to Big Spring in 6 hours. So I'm going to mark, here's San Antonio and here's Big Spring. So that's Juan's trip. Luann drove from Fort Worth to Big Spring in 5 hours and 30 minutes. So I'm going to mark, let's see, Fort Worth to Big Spring in 5 hours and 30 minutes. And we want to know who drove faster. I've made the map a little bit bigger. If you look at the blue trip, this was Juan. He went 298 miles in 6 hours. To change that to a rate of change, there we go. We divide 298, goodness, 298 miles in 6 hours. So I'm going to divide that, 298 divided by 6, that's 49.6 repeating miles per hour. So basically he went 50 miles per hour. Luann went 261 miles in 5.5 hours. So 261 divided by 5.5 is 47, approximately 47.5 miles per hour. And those are rates of change. So we can see that Juan drove a little bit faster than Luann. Oh, I forgot to mention, Luann's distance, of course, is the sum of the distance from Fort Worth to Abilene and from Abilene to Big Springs. So 151 plus 110 is where I got my 261. Well, this video is on rate of change, and that's all there is to it. Thank you so much.